Hi, and welcome back to Glassbox, writing automated protractor tests. Today we're going to continue where we left off and have a look at writing validation statements to validate our tests. We're going to write statements that will help to verify if our tests have passed or not. In turn, what that means is we will verify if certain conditions have been met as part of our automated tests. So, let's have a look at the test we already wrote. So, quickly recapping, we navigated to the JavaScript web app under the testroom.com, and then we populated an input field and we grabbed the text that was generated and printed it out to the console window. We then pressed the continue button and then selected the second option from the drop down box and then selected the last continue button. So if we were to automate that manually, what we did was we filled in this data, we then grabbed this information and printed it to the console window. We pushed the continue button, we then selected this second option, i.e. George the Turtle, and then we clicked on the continue button, and that was our test. And we used different locations to do that. But the one thing we didn't do is we didn't actually write any validation statements to check that what we were doing was actually true or not. For instance, when we clicked on, say, this continue button, we didn't check to see if the text we wanted was actually visible in this field or not. We didn't check other things such as the number of items in this drop-down. If we were to go back, we didn't check anything like if we were on the correct page or not. So why would we want to do such a thing? Why would we want to validate certain conditions on a web page? The main reason to validate conditions on a web page is to check that you're actually where you should be. It's also to validate that the functionality of the thing you're trying to write a test against still works. So for instance, if I were to say type in information here, so let's just say test data. Part of this functionality of this page is to generate this dynamic text as it is being written. Also, let's just say we type in more text, and then for some reason, through some kind of defect or bug, this doesn't appear here when it should. Our test would pick that up, in that it would validate that this text didn't appear and it would fail the test, therefore signaling to us that something is wrong. Other validations could be I select an option from this drop down. The fact that I'm able to select something, the fact that there are a certain number of elements on this page, we didn't check any of that. Also, when we went to this page, i.e. when we pressed this continue button on this drop down, we didn't confirm to check that if we navigated to the correct page or not. So these are some of the validations we're going to do now. So let's begin. So the first validation I'm going to do is just to check that when we actually navigate to this site, we're actually on the correct site. For instance, you might end up getting something like a URL not found or a 404 or something like that. And we can verify that we're definitely on a page that exists by simply getting the URL of that page. So let's do that. So to write validation statement in Protractor, when we write tests, we actually write what are called expect statements, and they look like this. So this is an expect statement. This is expecting something to happen, and then depending on the condition of this, either it will pass or it will fail. So let's just say really arbitrarily, we can say expect test string to contain test. So what do you think happens when I run this? Well, what we're saying here is this is the expect part of the expect statement. This is what we're trying to validate, and this is the equivalence we're trying to use to validate against. So what we're saying here is we're expecting this string to contain test. In other words, what we're saying is we're expecting test space string, this list or this sequence of letters and spaces, to contain this sequence of letters somewhere in it. And when we run this, this will pass. But if we say something like this, i.e. TEST, this exact phrase doesn't appear here, so this will fail. The reason we write expect statements is to tell us if a test has passed or failed. So if we were to be a little bit more specific, if we were to write an expect statement relevant to our test, if we wrote something like browser get current URL, and then we said to contain JS web app, because this string actually does appear here in our URL. If we were to run this, this would now check to see that the current URL contains JS web app. So let's quickly run this just to confirm this works. So let's save this test, and to run it, what I need to do is start WebDriver Manager first. Put that to a side, and I also need to navigate to the test folder and then run the configuration. So if we have a look, we can see that it ran a total of 1 test, which contained a total of 1 assertion, and there were 0 failures. So that means our test checked this as it picked this up as an assertion and found that the URL did indeed contain this JS web app string. We can do other types of assertions as well. So we can write another expect statement, this time slightly changing the contain and to check for an exact equivalence. So instead of contains, this time I'm going to use to equal. This will check to see that this is actually exactly the same as what I provided. So if I say this, when this runs, this will say it's found 2 assertions and they both passed. But if I were to change this slightly, let's just say I put in an X here, this will now say it's found 2 assertions where 1 passed and 1 failed. So let's save and run. So if you have a look, it's found 1 test, 2 assertions, where 1 failed. And it's told me what it failed on. So it expected this, but instead it found this. So this is what it was expecting. And this is where it was found. In fact, this is the only difference here. And we know about this. So writing this expect statement really helps us to identify if something's changed, i.e. if there's been an unexpected change in the application. Let's go ahead and write some more. So here, where we printed out our message to the console window, so if I quickly go back and we look at our past one, we can see that this printed out. Ideally, you don't want to do this. You don't want to print anything out to anything, because it doesn't really tell you anything. What you want to do is actually assert against it, so that we can see if something has gone wrong. So let's do that. In fact, before we do that, let's extract this into a different it test. So from this, let's remove all of this and make it a little bit more specific. So should be on correct page. Let's just call that for the moment. So in this test, we're going to specifically check to see that we can see this in the dynamically generated string. So let's get rid of this as well. And let's get rid of this as well. So we can say expect something to equal this particular text here. In fact, let's do a little bit of refactoring and tie this up a little bit more. So let's create a new variable called text message, which will be equal to this, and let's send this in as part of the send keys method instead. And we will check here the expect statement. So here what we're saying is we're expecting this message, i.e. the message we get from getText, or rather text to be more specific. So we're expecting text, or in other words, the result of getText, to be equal to this text here that we typed in. Let's also remove these expect statements since we don't want to repeat expect statements. Now if we run this, what should happen is this will now run two tests, where this we know will pass, and this we're expecting to pass. But instead of that, let's fail it on purpose first. So let's save and run. Okay, so it failed on two asserts. So it said, expected subscribe to my channel for more videos to equal subscribe to my channel for more videos. So this failed, which is good because we are expecting this fail. So let's get rid of that and save that. And it also failed on this exception as well, in that it was expecting this string to equal this string. So we missed out a / on it. So let's save that and run that again. And there you go. It found two tests with a total of 3 assertions and 0 failures. Fantastic. We also had a little bit more left of the other test that we removed. So let me quickly copy paste this. And let's change this to a relevant name. So in this test, we were checking to see that the text was dynamically generated. So let's just say should generate correct text. Okay. And here we will remove this assertion as well. In fact, we'll remove the whole thing because we don't need it. So the next thing we did in the test was, if we go back to home, after we populated information, we don't need to do this as part of this test because we're checking it here. We're not going to repeat the same test again. So as opposed to doing this, all we're going to do is press the continue button, select some drop down, and then press the continue button again. So let's quickly type that out. So it's element by model animal, then $sign to invoke the CSS. And then dot click. So we would have used this to select an option from the drop down, and then we would have clicked on the button and it was called continue and clicked on that. In fact, the first thing we would have done, now that I think about it, was probably click on the continue button. So if we quickly recap, we would have clicked on this continue button first, which we just did, select an item, which we just did, click on the continue button again, and then you can navigate to this thank you page. So if we do that, we've clicked on the continue button, we would then select an element, we then click on the continue button again, and that would be the end of the test. So a few other things to assert on this. Well, for starters, we can assert that there are at least a certain number of elements in this drop down box. So how can we do that? Well, here where we say we're going to select something but its value equal to 1, instead of that, let's just use the element.all method instead. So element.all. So what does element.all do? Well, element returns a single object. So for instance, here where we say element by model or element by binding, this is returning us either 0 or 1 element. No more and no less than that. But element.all returns us an array. In other words, it can return us 0, 1 or more than 1. So it can return us more than 1 element. So if you think about it, this is more than 1 element. There are more than 1 items in this list. So it makes sense for us to use element.all to help us get more than 1 element as part of that list. So we can use the .css locator on this. So what can we use as part of the CSS? So if we do a quick inspection of this element, we can see that it has a class, which is good. So let's use this class. So to represent class in a CSS expression is dot name of the class. And we're more interested in these option fields. So if we say dot and then the class name followed by a space and then the name of the tags we're looking for, what this does is this looks for any child nodes which belong to the parent node. So I'll probably do a much more relevant video on using CSS in a lot more detail, but for the moment I think what you just need to understand is this is looking for a class which identifies an element, and the space followed by this name here, in this case is option, is identifying all child nodes which belong to this parent node which are of type option. In other words, it will grab all of these option tags. So once we've got all the tags, in other words we're using element.all to get all of these tags, what we can then do is use the then function on this. And in the then function we can pass in effectively this array. So in this case we'll just call it items, and now in here we can expect, or rather we can write expect statements on this items array that we passed in, which is returned as a result of doing an element.all. So let's do that. So we can say expect items length. We can invoke this length method on an array, and we'll use the to_be assertion to check that it has 4 items inside it. We can also get specific ones if we want, so we can say expect items at index 1 get text to be George the turtle. This will now do an expect assertion on this items array. First, where we check the size of the full array, and second, where we check a very specific one. So let's save this and run this and see what happens. Alright, fantastic. We found all 3 tests, 5 assertions, and there were no failures. And let's just change this test name to reflect what this test actually does. So let's just say should check the correct number of items in dropdown. Let's write one more test to check that when we navigate, or rather once we're on this thank you page, that we're actually on this thank you page. And one way we can do it, or there are multiple elements we can check. What we'll do is we'll just check to see that it's got the confirm HTML in the URL. That way we know we're on the correct page. So if I just copy this, and let's change the name first, ideally because the name is what we should be changing first as opposed to changing as the last thing to change. So let's just say should check user is on the thank you page, and let's get rid of all of these elements because we don't want to do this. Why don't we want to do this? Because the focus of this particular test is to make sure that we get to this thank you page. So we can remove this as well. So effectively what we're doing is we're going to navigate to the site, we're going to click continue 2 times, and then we're just going to do an expect on the URL. So we're going to say browser.get current URL to contain confirm. So let's save and run this. Fantastic. So it found all 4 of our tests, a total of 6 assertions and no failures. So we can see that we've actually written different tests which, although they have similar steps, they actually test different things, they validate different things, and it's really important that we use validations quite strictly when we write tests. A test shouldn't have lots and lots of expect statements because it almost breaks the test. So for instance, here we've written 2 expect, both of which are very similar to each other and both which do different things. In essence, because this checks for equivalence, it almost makes this expect redundant. There's no point in having this because this is explicitly covered by this. So we can get rid of this. In the next one, we did an assertion check to check that the string that was generated was the same as the string that we passed in, confirming that that functionality works. In our third test, we checked the length of the number of items in that dropdown, and we also checked for a very specific one passing in a string. In our final one, we just checked to see that we were on the correct page if we went through what's called a happy path, i.e. we did the minimal amount of clicks needed to get through the full end-to-end flow of that journey, and just to check that we were on the right page. So here we've broken down what started as one big test which didn't really do any checks into 4 smaller tests which check for very specific functionality for this flow. If a part of the flow breaks, because we've broken it down into 4 different tests, the relevant test would fail and not all the other tests, and this will help us to pinpoint the issue. In our next video, we will discuss how to make this test a little bit more robust and a little bit more manageable by looking at what are called the before and after methods when writing tests. And that's it for this video, folks. Thanks a lot for watching. Bye. Hey guys, thanks a lot for watching my video. If you already haven't, hit the subscribe button to stay up to date with my latest videos, which I release every Wednesdays and Sundays. Also, follow me on Twitter and Facebook. Until next time.